Hi, this is the second video on the playlist where we're looking at sample papers. So this particular one is the higher tier for Edexcel and it's paper 3, so it's calculator paper. If you follow the link below in the description, you'll be able to download this paper and have a go at the questions themselves. I'm going to make it so that each of the videos is about 20 to 30 minutes in length, and if you keep stopping and starting the video, have a go at each of the questions and then you'll be able to have a look at the solutions as well. Okay, so in the previous video we covered up to question 5. From this video, or at the beginning now, we're going to look at question number 6. Now question number 6 deals with, actually it's just lowest common multiple. So what they're looking at is, initially at least, the lowest common multiple of 8, 6 and 5. Well, probably the easiest way of doing that is actually firstly to work out the LCM of 8 and 6 and then the LCM of 8, 6 and 5. Okay, so the first one is the way I would normally do it is do a little quick factor tree really for each of these. So this is a prime factor and these are two prime factors for 8. Okay, now if we look at 6, well, that's just basically 2 and 3. Okay, so the way I would do that is I would write that out and say, well, actually the LCM of 8, if I write out the product of its prime factors, it's 2 times 2 times 2, and 6 is going to be equal to 2 times 3. Therefore 2 and 2 are common, so that's actually the HCF. Okay, that's the highest common factor. The highest common factor is going to be equal to 2. And then the LCM is the highest common factor, 2, times whatever is left, which is 2, 2 and 3. So times 2 times 2 times 3. Now if I then calculate that out, that works out at being 24, because we've got 2 times 2 is 4, times 2 is 8, and 8 times 3 is 24. So the LCM of 8 and 6 is 24. Then if we look at the factor tree for 5, we've basically got 5 and 1. Okay, so if we multiply this 24 by 5, if we include, if you like, if we include the factors of 5, that's going to be equal to 24 times 5, which equals 120. So the LCM of 8, 6 and 5 are going to be 120. Okay, now I'm aware that there are different methods of doing this. This is a very quick and straightforward method using factor trees, and if you're not sure, have a look at some of the examples within the channel. Okay, however, that's not the whole story, and one of these things with this is you have to be really careful to answer the question. So it actually says that in each packet of buttons you've got 8 red and 6 silver and 5 gold in each packet, and then the question is how many packets of each colour of buttons did Liz buy? So in this particular case she bought 120 of each of the buttons, but in order to answer the questions we've got to work out how many packets. So for the first one, the packets of red buttons, it's going to be 120 buttons and there's 8 buttons per packet, so that's going to be divided by 8, so that's actually going to give us 15 packets of buttons. Okay, silver buttons, well, again, you've got 120 silver buttons. There's 6 in each packet, so that's going to be 20. And then finally, gold buttons, you've got 120 buttons. There's going to be 5 in each packet, so that's going to give us 24 packets of gold buttons. Okay, I hope that's okay for you. As before, please do add a comment if you're not sure about anything. I'll always come back to you. Okay, let's move on then to question number 7. Question number 7 deals with cumulative frequency. Now these are the kind of questions that do come up fairly frequently, so it's always worthwhile checking these and having a go at some of the examples. This particular one isn't too bad really. All they're asking you to do is initially at least plot the cumulative frequency graph? Okay, well, the first thing is that we can plot it. You need to remember with cumulative frequency, it's an accumulation. So what you're doing is you're plotting this 10 against the 8 and this 20 against the 23 and so on and so forth. Okay, it's not the midpoints. Okay, it's the accumulation. So just remember it's the accumulation. So the first thing I'm going to do is I'm going to plot, as I've got here, 10 in the cumulative frequency against 10 rather marks against 8 in the cumulative frequency. Okay, so if I go down to my graph, I've got 10 marks here and it's going to be 8, which is about that point there. And what I can do, and I'm going to have to do this while I'm talking to you, is kind of work through this fairly methodically to make sure that I can plot each of the points relatively accurately, and hopefully you'll be able to see here what I'm doing. It does require a little bit of concentration, so if I'm stumbling over my words, then hopefully you'll forgive me for that. So that's going to be 50 to 74, which is going to be there, and then I've got 60 to 80, which is going to be there. And what you'll find is when you draw the actual graph itself, you find a very typical cumulative frequency curve goes something like that. It's quite a nice curve. Okay, and then the question itself says find, this is part B, it says find the median mark. Okay, this is this one here, find the median mark. Well, the median is the value of, in this particular case, the 40th students. There's actually 80 students that have taken this particular test. So the 40th student, it's actually 39.5, but the 40th student in this is going to be this student across here. So if I take that across and I take that down, and usually just taking a ruler and marking it in will be sufficient. It's probably, to be fair, it's probably not a bad idea to do this as a matter of course, because you're really showing the examiner that you know what you're doing when you're doing this. Now, there is a little bit of leeway on this reading because not everybody's cumulative frequency will be the same. Now, I made that 27. It's not, I can see here that it's not particularly good, but it should be 27.5, something like that, I would have thought. And they will give you a bit of leeway on this, so I'm going to write down 27 on that one. Okay, so let's then move on to the second part of the question, and it's just really the same as drawing a box plot. Now, I'm going to hope that you've printed this off and you've had a go at this question, because it will refer back to this information. So it is really a box plot, because if you look at the information that you've got, what we're saying is that 3 times as many students fail the test as pass the test. Okay, 3 times as many students fail the test as pass the test. So what we're saying is that actually there must be 4 groups of students, okay, of which 3 groups will fail and 1 group will pass. Okay, I hope that's all right with you. Sometimes a lot of this maths work is actually trying to decipher the English. Okay, so really I could actually draw that effectively as a box plot, because what a box plot represents is this is the middle 50%, and this is 25%. And this is also 25%, okay? So 3/4 of this is that group in here. So this group in here are the 3 out of the 4 groups who fail, and this group in here are the 1 out of 4 groups that pass. Okay, now if you go back to the graph itself, what it tells you is that this particular mark, which is the upper quartile, is going to be in this particular case 37. Okay, and you'd have to go back and check with the graph on that, but you're looking for the reading at a cumulative frequency of 60. okay, and that should give you around about 37. Again, there's a little bit of leeway on this, okay, but what we're saying then is that the lowest possible pass mark must be 37, because this is the lowest mark at which students will either pass or fail. Okay, I hope that's all right for you. Sometimes these questions, they are a little bit tricky just to kind of navigate the English, but that's basically what they're getting at with this particular question. Okay, let's move on then to safer ground, which is question number 8, which is writing this in standard form. All right, fairly straightforward this. It's a 1-mark question. So all you're doing is you're telling the person that you've actually moved the decimal point from here 1, 2, 3, 4, 5 places. Okay, remember the standard form has to have the first number between 1 and 9. So in this particular case, I've changed it to 6.8 and I've moved the decimal point backwards 5 places, so it's 10 to the minus 5. Okay, hope that's all right for you. Again, if you're not sure about standard form, please do practice this when you have a look at some of the other playlists within this particular channel, and also have a look at 3-minute maths, and that'll give you some papers for you to download and have a look at. Okay, so let's move on then to question number 9. And question number 9, again, relatively straightforward, 2 marks that you need to be aware of with this, and that's actually going to be to factorise y squared plus 7y plus 6. All right, well, if you're going to factorise that, you need to find 2 numbers that when you multiply them together make 6, and when you add them together make 7. Okay, so it's not entirely straightforward, because most people look at that and think it's 3 and 2, but actually 2 numbers that you multiply together to make 6 will be 6 and 1. Okay, could also be minus 6 and minus 1, but in this particular case we're going to add them together to make plus 7. So plus 6 plus 1, okay? And we would write that as y plus 6 multiplied by y plus 1, okay? And that would be the answer to this particular question. Okay, and then we've got this next bit, which is dealing with an inequality. Inequalities are best kind of dealt with more or less as linear equations, really, but you've got to remember to keep this greater than, less than sign in the middle. Okay, so what I'm going to do is I'm going to take this x value, I'm going to move it over to this side by taking it away. So I end up with 5x plus 4 is greater than 17. Okay, I then need to move this plus 4 over to this side, so I'm going to take it away again, and that's going to be 5x is greater than 17. Take away 4 is 13. Okay, and then if I divide through by 5, I get x is greater than 13 over 5. Now, most mark schemes will be absolutely fine. If you write x is greater than 13 over 5, you can do that, no problems at all. However, if you prefer to write it as a mixed number, you can write it as 4 and a third, and that's absolutely fine as well. Okay, let's move on then to part C. N is an integer with, that means a whole number. So it's one of these strange maths words that they come out with. It just means a whole number, with minus 5 is less than 2n, which is less than or equal to 6. Okay, so where you've got this value of 2n, what I'm going to do is I'm going to divide through all of that by 2, because then I can write this as minus 5 over 2. If you prefer, that's minus 2.5. is less than n, which is what we want, is less than or equal to 3. Okay, so if I just draw a very quick number line for that, I would have minus 2.5, which is this value. Then I'd have minus 2, minus 1, 0, 1, 2 and 3. And what we're saying is that inequality runs from here through to here. Now, because it's actually equal to, I'm going to fill that in. Okay, and that's common convention, that if you fill it in, it just means it includes. And then the number line runs, or the inequality runs across there. Okay, so the answer to the question really is integers is all the whole numbers. So all the whole numbers that are included in this inequality are going to be -2. Remember, it's not 2.5 because it's not a whole number. -1, 0, 1, 2 and 3. Basically that will answer that particular question. Okay, I hope that's all right for you. Let's move on then to question number 10. Okay, so question number 10 is the function f is such that the function of x equals 4x minus 1. Okay, and then it asks you to find the inverse function. Now, I'm aware that there are different methods of doing these sorts of things. If you follow some of the on the channel, there is a playlist that deals with inverse functions, and you'll be able to have a look at some of these questions for yourself. And please do practice these questions. They do come up in exam papers, but they are usually only a couple of marks to do, but it's well worthwhile because it's a relatively straightforward thing once you follow the method. So what we do is we say, actually, rather than function of x, we're going to write y equals 4x minus 1. Okay, and then I'm going to solve, or at least I'm going to make the subject of this particular equation x. And the way I'm going to do that is I'm going to take this -1, put it over here, so I'm going to get y plus 1 equals 4x, and then I'm going to divide through by 4, so I get y plus 1 over 4. Okay, and then I basically change this value of x, okay, to the value of y, and I write it round the other way around. So y equals x plus 1 over 4. Okay, it's just a technique and it's just a way of doing it. And then the final little bit is I change that y back again to function -1x equals x plus 1 over 4, and that's actually the answer to this particular question. So the only tricky bit with that is this changing this around from x back to y, and then changing this y to x over there. So it just swaps everything around, and it does make it, providing you follow that way of doing things, it does kind of work for you. Okay, then the final part of this one is the function g is such that g of x equals kx squared, where k is a constant. Alrighty. Okay, so, and then it says given that that equals that, work out the value of k. Alright, well, in order to do that, what I'm going to do is I'm going to take this g of x and I'm going to plug it straight into here. Okay, so what they mean is this g of x is this, okay, put it straight into here. And again, if you look at the playlist on functions, that will help you a little bit. So what I'm going to write is the function g of x equals, and rather than writing 4x minus 1, I'm going to leave the 4 in place, and rather than writing x, I'm going to write kx squared. Okay, so you kind of work backwards with these things. You've got your g of x, and then you're going to put it into this f of x. Okay, so that 4 stays, and then I'm going to change that to kx squared minus 1. Okay, and then if I multiply that out, I'm going to get 4k x squared minus 1. All I've done is I multiply that 4 into the term in the brackets. Okay, so now what we've got is a function g of x which equals that, and we're told that given that equals 12, we've got to work out the value of k. Okay, so let's just put that into the actual calculation. So we're told that the function g of 2 equals 12. Okay, so if we're saying that this is correct, then where we've got the value of x, which is here, I'm going to change that to 2, and that whole expression is going to be equal to 12. So let's just write that out. I'm going to write 4k, which is the unknown, is the bit we're trying to solve, and then we've got 2 squared, okay, and that equal minus 1, which is this bit here, and that equals 12. And then really it's just a case of solving this, okay. Now if I look at this, I've got 2 squared is 4, and then I've got 4 times 4, which is 16. So I can write this whole expression here as 16k, and then I've got minus 1, and that equals 12. Okay, I hope you're following this all right. I do appreciate it's not the simplest of questions. It does take a little bit of time to kind of work through. Okay, so then I need to add 1 to both sides. So I could write, I'm going to just write it up here, that 16k equals 13, okay? If I divide through by 16, I've got k equals 13 over 16. And that's actually the answer to this particular question, 13 over 16. Okay, so I hope that's all right for you. It does take a little bit of time to kind of work through, but if you can imagine, what we're saying is that we've got this g of x value, and we're going to plug it. G of x is kx squared, which is there, and we're going to plug it straight into the value of f of x, which is this one here. So if we plug it straight in, then that will give us an expression that we can then use to solve by knowing the two values of what the expression actually works out as, which is 12, and the value of x. So once we plug these two numbers in, it will enable us then to work out the value of k, which in this particular case works out as 13 over 16. Okay, so it's 20 minutes into the video. I'm going to move on to question number 11, which is a little bit more straightforward. It's actually using the quadratic formula. Now the reason I know that is because it's very helpful. It says give your answer correct to 3 significant figures. Now as soon as you see that, it's all about then using the quadratic formula, okay, because it's a calculation. So what we're saying is that a equals 1, b equals minus 5, be careful about this minus 5, and c equals 3. If you're not sure what I'm doing, please do again have a look at the playlist on quadratic formula, and that will give you a way of solving this. Okay, so let's write the quadratic formula out. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now you're going to need to know this. It's not given to you now on the exam paper. It used to be, but unfortunately it's something you need to know. So if you get yourself a post-it note, always write it down when you're doing your revision, and hopefully you'll be able to learn it and remember it. Okay, so what this is going to do is give us the two values of x that are solutions. In other words, these values, the two solutions to this particular quadratic. Okay, so let's plug in now the values. So I've got minus b, but I've got to remember that b is minus 5. Well, a minus times a minus is a positive, so actually that becomes 5 plus or minus the root. Okay, so b squared, well, that's minus 5 squared, which is the same as saying minus 5 times minus 5. B squared is minus 5 times minus 5. Well, that's going to give you 25. Minus, okay, 4 is all right, a is 1, and c is 3. So minus 4 times 1 times 3. Okay, and you'll note that as I have done in previous videos, when I put a little dot there, it just means multiply. I just think it's a little bit neater. At the bottom here, I've got 2 times a. Well, 2 times 1 is 2. Okay, so my best advice with these is never to pick up the calculator until you've calculated this value. This value, if you do higher maths, is called the discriminant. Okay, and it's quite important with sketching quadratic equations and all that sort of stuff. Okay, so what I would do is, using mental arithmetic, I would just work out that I've got 25. Now you got minus 4 times 1 is minus 4, and minus 4 times 3 is going to be minus 12. So I've got 25 minus 12 in here, which is 13. And that's divided by 2, so that's one value of x. And then my other value of x is x equals 5 plus, beg pardon, minus the root of 13 divided by 2. Now, unfortunately, they've not given us a whole lot of room on this particular bit, but I'm going to kind of carry on past the line there. So when I plug this into a calculator, I get 4.302775638, and then I also get equal to 0.6972243623. Okay, now you don't kind of have to write all this out. I don't think, for completeness and the sake of the video, it's always a good way to do it. Okay, but the question has asked us to give the solution correct to 3 significant figures. Okay, so the two solutions are x equals, so this is 4.30, so the third significant figure is 0, so that's going to be 4.30. It's not going to change because there's only a 2 after it. And then I've got x equals, third significant figure is 7. Well, that again is going to stay the same as 0.697, correct to 3 significant figures, and that would be the answer to this particular question. Okay, so I'm going to leave it there, and then we'll move on next time from question 12 onwards. I'm sorry there's been a little bit of noise in the background, but hopefully you were able to hear the video okay. I hope it's been okay for you. Please do leave a comment if you're not sure about anything. I'll always come back to you. Subscribe to the site, and I'll look forward to seeing you inside the next video.